the 6 steps in MLOps, and we wanted to discuss the rest of them. Okay, so the next step after model selection, once you have selected your model, what do you want to do next? So you want to, yesterday we discussed a bit about it. There is a term called training your model, and this is applicable when we do supervised learning. Even in unsupervised learning, we don't have training or testing, but here we have something called training your model, all of you. And we do model training on the, what did I say? In supervised learning, we teach the machine with examples where the target variable is known. So as a teacher or as a trainer, suppose I have, right, 10 questions which are based on, say, some concept. Okay. Some 2 or 3 concepts are there, 2 concepts are there, and I have a bank of 10 questions. Now, if I'm teaching you all, will I use all the 10 questions to teach you, or what I will do? I may use out of this maybe 8 questions to teach you and 2 questions to test you. How many of you are getting what I'm saying? So this 8 questions are known as training data. They are known as training data. Does it make sense? Yes or no? So in machine learning, there is a concept, if you are using supervised learning, that in order to train your first you have to train your model. So what you will do, you will split your data. The data, yesterday we discussed, say, the salary data, for example. You will split 80% of that into training and 20% you will use for testing. Now this ratio can change. If you have a large amount of data, you can use 70% for questions and 30% for training. So these variations can be used, but ultimately you need to split your data into train and test. So step 7 is what? You train your model, and that is called as model training. So here what you will do, here you will first split your data into test and into train and test, and then you will tune the hyperparameters. So what is hyperparameter? When you use a model, I will show you later, when you use a model, you will have to tune that model, and in that model, there are various parameters, hyperparameters, we call them. So you tune them and then you come to your final model. Okay. So now, as I said, once your model is trained, the next step you will do is model evaluation. Okay. This is important step. So you have trained your model. Now what you will do? You will test your model. And then there are something called performance metrics. Performance metrics. Okay. So this is important. When you are building a model, say a classification model, your performance metrics will be accuracy, recall, say precision, F1 score, and there are others. Whereas in regression, you have another set of performance metrics, that is RMSE, R square value, MAE values, etc. So what I'm trying to say is every model, even unsupervised learning, have their own performance metrics. What do you mean by performance metrics? Say if I'm teaching you, how will I evaluate you? The 2 questions which I'm using, how will I evaluate you? I will evaluate you based on certain scores, or I will grade you on certain marks. So every correct question you will get 1 mark. So there are performance metrics which are, relevant to how you evaluate your model. So what I was explaining is like how a teacher will evaluate a student. Performance metrics of a model is evaluated by certain metrics. So now with this performance metrics, there I've listed some of the performance metrics. So at this step, what you do, out of the training and testing parameters data set, you will test your model with the tested data set, and you will check how the performance of the model is. If the performance of the model is good, what you will do, you will go ahead and deploy the model. And if it is not good, if the model requires, if you find that in testing it is failing, all of you, we can do again something called as model tuning. Okay, model tuning. So what is model tuning? In model tuning, what we will do is We will improve the performance by hyperparameter tuning, as I mentioned earlier, or we will do something called cross validation. There are a lot of ensemble techniques, so that all will be applied. Okay. Once your model is finalized, what you will do is step 10, model deployment. Step 10 is model deployment. And here you will deploy via API. You will use cloud platforms and you will containerize using Docker and Kubernetes. And lastly, model monitoring and maintenance. Once you have deployed your model, what will you do? You will start tracking its performance. That, okay, in production, how it is performing. So there you will retrain the model if you are getting new data. You will do some logging of your errors. And if there is delay in your model output, then you will also try to see what are the issues related to your model. So when you say track latency and throughput, for example, suppose you are using a mobile and it is taking a lot of time to open your or unlock your mobile. In that case, that model, it will lead to latency in your model. You will not want a mobile which does facial recognition or thumb recognition in say 10 seconds. You cannot wait to unlock your mobile in that much time. So you will do model monitoring and maintenance. And if you find that the model requires retraining, then the last step will be model retraining, which we call the feedback loop. And through this loop, you can restart the whole process. All of you, this will be your step 12. So if I have to give it in a nutshell, these are the steps which at a higher level are being followed in machine learning. First is you define your problem, then you collect your model data, then you clean your data, you do EDA of your data, you do feature engineering of your data, you do model selection, training, evaluation, tuning, model deployment, model monitoring, and then retraining. So these would be the major steps of your machine learning steps. In maintenance, what we supposed to do apart from retraining? So in model maintenance, track latency and throughput. Essentially, you check if there is issues in the model in terms of how it is performing and whether you need to make some changes in how the data is being say pushed to model, etc. First, I hope this is clear. In model maintenance, it's not only about checking that the model is doing well, but in model maintenance a lot of other issues can crop up, like data can drift, or there is something called model decay, with like if you're using a hardware, how with time it decays. So a lot of time with new data coming in, the model also starts becoming lesser accurate. There will be technical failures, so you will be learning a lot about this. For example, APIs, we'll be calling APIs. So suppose there are API failures, infrastructure downtime, some memory leaks happening. So all those issues of technical difficulties will be there. Most places you will fall that there is a monitoring ish gaps. What are monitoring gaps? That no system in place to decay, to detect when the problems are happening. So that also issues are there. And biasness in the model. So you will learn that, maybe the model is biased towards one output. That may also happen. So all these issues are part of model maintenance. There is no commission to end the life cycle. No, this is a continuous integration and deployment process. So obviously the retraining will not happen unless we face any of these issues, and that is where the life cycle may end. I hope now this cycle is getting clearer. So if you see here, the cycle is moving in this way: preparing data. Now we have three steps here: problem, data collection, data cleaning, EDA, feature engineering. What it has done, it has clubbed them into prepare data. So once your data is prepared, you're exploring your data. That kind of leads to EDA and feature engineering. Once that is done, then you do your model building. So that is leading to model selection, model training, and evaluation. Once your model is ready, you register that model, you save that model. And once your model is saved or registered, it gets deployed. Once it gets deployed, it gets monitored. And once it is monitored and you find that there are issues in the model, you retrain that model, and that is what I was saying as a feedback loop. You retrain your model, and this cycle goes on. Now your whole job will be to create this life cycle similar to DevOps, MLOps. So how do we track preparation of data? How do we track exploring of data? How do we track model training and model evaluation, model testing? How do we track registration of our model or saving of a model? How do we track deployment of the model, monitoring of the model, retrain, and how do we automate this? So we will be learning all these tools in the sessions. So what I'm trying to say here is that the above steps, depending on the size of the problem, there will be multiple teams or associates working on the problem. Okay. So what I'm trying to drive here is you also need to start thinking in terms of collaboration. So suppose someone is working on different steps. How do you collaborate with each other? Also, even if you're working individually, how many of you are able to understand that there are a lot of moving pieces here? Your data can keep on updating. You may want to change your model sometimes. You may want to change your evaluation strategy. So what I'm trying to say is each and every step have moving pieces. They may keep on changing. So it is very important, say at the end of the machine learning exercise, you have built 100 machine learning models with different variations of the data set. As a MLOps engineer or ML engineer, your role will also be to ensure that you are tracking each modeling process or modeling step. I'm saying not only automating, but I'm using another term now, tracking, so that you can track which ML model was trained with what data set, with what parameters. All those things need to be tracked, and this is also the job of a ML engineer. Is it making sense to all of you? Yes or no? So the first thing which I will be teaching you all, I'm going to the next step, which we call versioning tools. What did I say? That we want to track experiments, we want to track our codes, we want to track our data. A lot of tracking will be required. So we will be learning a lot of versioning tools. So some of the prominent versioning tools we will be using is called Git and DVC. We'll be learning more, but these two will be the prominent one. Now, what does Git do? It versions the codes that are involved in the machine learning operations. Okay, machine learning life cycle, you will be writing a lot of code for each of these steps. So we will version that with the use of something called Git. Similarly, we will be versioning with DVC the data and the models used in the MLOps. Which data set, how did the data get updated? All those versioning will be done using what we call DVC. First tool that we will learn is Git. So we'll understand what is Git, why is Git useful for MLOps, and key benefits of using Git. Okay. So what is Git? Git is what we call, all of you, version control system. Okay. And what is it mainly used for? One is we want to track changes over time. Sometimes you may want to revert to previous versions, like you have developed some code, for example, and you want to revert to the previous version instead of the latest version, which may have more errors. Then how do you manage that? So you can't remember what changes were done in each step. I will be explaining with example. You'll get to better understand it. So if I have to put it in a nutshell, Git is like a time machine. Okay. And also, along with Time Machine, it allows you to collaborate. So collaboration tool for what? For our codes, some notebooks that we will create, and config files we will create. Sometimes data files also we will use in Git. Is it clear to everyone? So this is what we will call Git as. It's like a time machine plus collaboration tool for our codes, notebooks, config files, data files, etc. Now, why is Git useful for MLOps? Git is useful for MLOps. So you will get to learn this, hear this a lot. It is useful for something called reproducibility, okay, collaboration, and traceability. Who did what? So in MLOps, these are the foundational things why we are doing or learning MLOps. That you want to ensure that your machine learning life cycles are reproducible. You can collaborate in your life cycle of machine learning, and you can trace what are the changes happened, who made them, when it was done. So for that, all these enablement, Git is one of the major tools. So if you see, these are the features why we are using Git. Currently, you may understand them as more theoretical, especially those who are new. But as we will learn, we'll do hands-on it, you will understand these are the features why Git is useful for MLOps. Code versioning, experiment tracking, team collaboration, reproducibility, rollback capability, CI/CD integration, auditability and governance, work with model artifact and versioning tools. So all these things you will get to know as we do hands-on. Okay. So for now, let me explain you. Now I'm coming to the tool part of it. So I'm not going into the details. We will learn about it as we do the hands-on. So the first thing is, what is Git? I have already told it's a version control system. But if you search Git, it takes you to this website which says Git is a free and open source distributed control version control system designed to handle everything from small to very large projects with speed and efficiency. So it's like a software. So when I say Git, it's not a framework, it's not a methodology, it is a software. How many of you are getting what I'm saying? So it is something that you need to install in your system in order to do this. That is collaborate and version your codes. So Git is one of that. But does it mean that Git is the only tool? If you see here, these are GitLab. If you see GitLab is also another software which does the same thing. Okay, it is also a versioning tool. So GitLab is also one of the versioning tool which is similar to GitHub. Now you may ask, what is GitHub? What is GitLab? Why are you talking all these words? So essentially, if I have to collaborate with you, for example, I am based here in Bangalore and you are based somewhere in another part of the world. How do I collaborate? Say you are based in US. How do I collaborate? So will you collaborate from my machine, from my local machine? The answer is no. You will require a repository like Google Drive, for example, or some storage bucket which is online or on cloud. How many of you are getting what I'm explaining? So for that, there are services like GitHub, GitLab, etc., which are what we or Bitbucket. I think that's the third one. I have also used that a lot. So these are some of the Git repositories. So what they help you? They help you store your code online via Git, GitHub, GitLab, Bitbucket, and these are all Git repositories. And through this repositories, we collaborate. How many of you are understanding what I'm explaining? So in this coursework, we will be using something called GitHub. How many of you are clear that GitHub is a separate software? It's a repository similar to Google Drive, how we save our Gmail account, etc. on cloud. Here we can save our codes. So this is called GitHub. And similar to GitHub, you have GitLab and Bitbucket, which does the same thing. GitHub provides you with free services. It's also having enterprise license. GitLab, etc. are not free. They are also paid services. But GitHub is more common, more widely used. So we will be using GitHub in our classes. So what I want all of you to do first confirm is, please create, okay, a GitHub account. All of you please sign up. If you are already signed up, log into your GitHub account and confirm to me. I am working for a machine learning project. So first thing we will have to do is we will have to install Git in my, so I will be using two terms here. One term that I will be using is local machine, and then we will push it to cloud. Now, what do you mean by local machine? Local machine is the machine where I am doing my development work, dev work. So currently I'm working on a desktop, and this is my local machine. For you all, if you're working say from your laptop, that becomes your local machine. How many of you are clear with this term? Now, the first step is, how do you install Git? You have created your GitHub account. Now, how do you install Git in your local machine? So we need to install this in our local machine. So here, if you see in Git, you can see download for Windows, Mac build. So from here, you can download and start working on Git. So what you will do, once you download it, it will give you an installer, and you can run that and it will install Git in your local machine. But what it will do is it will just install Git in your local machine or environment. But how do you work on it? So for that, you may require a command tool. Okay. So for that, we have something called, as soon as you install Git, you will also install something called Git Bash. So it will automatically get installed once you install Git. And what we will be doing is we will be writing commands for Git. Okay, we will learn those commands for Git on Git Bash directly. We can write it there. Or now I am coming to the next part of it, which is where will you code? So Git is used for versioning your codes. But my first question is, where will you code? So for coding, in most of machine learning, we will be using something called Python. So we have already learned that how to use Python, etc. But in your local machine, if you all remember in the first class, I told you to install VS Code, or you can also install Anaconda. So for example, in this coursework, I will be using Visual Studio Code. You can see here, it's already switched on. Let me open a new session. So what I will be doing, I will be using VS Code in my local machine to do coding. So we will be using, this is how VS Code looks like, and this is where we will be coding. Now in VS Code, if you see here, you will see that it gives you option when you go to the terminal here at the bottom where you can write say some command. It gives you option here. You can also write your commands in Git Bash directly. So this is called command prompt, and it also gives you an environment to write your codes in Git Bash, your commands in Git Bash. So in VS Code, you can write your commands in terminal, or you can write your commands in Git Bash directly, or you can open Git Bash separately and write your command. How many of you are following what I'm saying? Is it making sense, or is it too complicated? So I request all of you, if you want, you can also install VS Code in your local machine, because I'll be using that for my coding purposes. You can obviously you can use any other GUI. You can use PyCharm. You can use Jupyter Notebook is also there. A lot of things are there, but we will be using VS Code, and I'm going to now create a repo. What I'm going to do, I'm going to create a repository in my, okay, so in my GitHub, I'm going to create a repository. Let's name this repository Skillfy Morning and 2707. So what we'll try to do, I will push all links and material. Okay, I'm creating a repo. In this repo, I'm going to track all my codes, all my links which I want to share with all of you or collaborate with all of you through this repository. Now, one thing unique here you will see is Skillfy Mon 270 is available. What does this mean? It means that all the repository name needs to be unique. Okay, so owner slash repository name, this is my login ID, slash repository name, that needs to be unique. So here I'm creating this, I'm making it public, I'm adding readme file. It's a good practice to do that. What it means that it will just initiate one text file with this repo so that it is visible and it is initiated. Okay, and then I can choose some licenses. Different licenses have different repercussions. For example, some of these licenses may not allow using your code. Some of them may allow using your code commercially. Some of them may allow using it only for academic. So you will have to understand. For now, I'm keeping it none. There is a concept of branch. We will understand. First, let us create a repository. So what has happened? This is a repository which has been created, and it is unique. As I told, it is unique in the world because the username, the slash, the name of the repository is unique. So what I'm going to do, using this link here, and I'm going to clone this into my local machine. How many of you are getting what I'm saying? So what we have done is we have created a skillfy underscore mon underscore 2607 repository where I have created it. I have created it on GitHub. And now what I'm going to do, I'm going to clone all of you, clone this repo into my local machine. So this is my local machine. Okay. So suppose I create a new folder here and I name this Skillfy 27 June. I'm creating a folder here. Okay. So this is a folder which I'm creating and to do in this my local folder. I'm going to now open Git Bash here. I can also work with VS Code, but for simplicity, I'm working on Git Bash here. I've opened Git Bash here and I'm going to clone. So I'm copying this link. I'm going here, git clone, shift insert. So I've done that here and I'm pressing enter. So all of you can see in my folder now, quickly all of you, this was the folder I created, Skillfy 27 July. Inside this, can you see Skillfy Mon 2707? The same name as is here, Skillfy Mon 2707. It has now replicated, that folder has been replicated in my local machine. If I open this folder, you can see there is a readme file which is similar to this. Okay, it's opening here. So if you see Skillfy Mon 2707 hashtag, that's the same readme file which is here. Push all links and materials into this repo. The same thing is written here, push all links and materials into this repo. So I have been able to clone this in my local system. And there is a .git file, .git folder. I will come to this later. We'll try to understand this later. So essentially for now, this .git is a folder, which means that this folder is now being tracked by Git. The one thing I wanted to share with all of you was what? I wanted to share, for example, I'm creating in my local machine collab links. Okay. Collab links. And in this, I'm creating a new folder, new text file, for example, which I'm saying Python intro class 1 to 4 links. So if you all remember, for Python in intro, we did everything in one link of collab. I have been sharing this with all of you, but obviously you may want to look at it later also. So what I'm going to do, share anyone with the link is an editor, copy link. So this link, now I am doing what? I'm going and pasting it in here. How many of you have followed me till here? That I have kept my link here in collab in a text file. Now, is this there in my GitHub repo? Can you see this folder? Yes or no? So first is Git. When you install Git from your this Git SCM, I'll share this link with all of you. So from this, when you install Git in your Windows, I'm assuming you're working on Windows, Git bash will be installed automatically. What I'm going to do now is, all of you please note here. So I'm going to Git bash, and now I have created a new folder which is there in my local machine, but not in my cloud machine. So what I'm going to do, Git status. All of you, what is the second command I'm putting? Git status. It is saying, okay, I'm not in the folder yet. If you see, I'm in the folder Skillfy 27 July. I should be in the folder inside where Git is there, which is Skillfy Mon 2707. So if I do ls, it is saying there is a one more folder. So cd Skillfy Mon 2707 ls. Now here, if you see Git status, if I do, it will say that there is extra untracked file collab links. How many of you are following what I'm saying? So what it has understood that there is a new folder created, collab file, which I am not tracking yet. So what we need to do, we need to pass a command called git add dot. I will be sharing these commands with all of you, don't worry. So git add dot. And once I do this, after this, if I say git status, you can see that, okay, now I am able that these changes are yet to be committed, but I am tracking the changes in these files, the new files that you have created. Now, what I'm going to do, git, after git add, I'm going to git commit m with the message that collab links folder has been created, a message I'm passing. And what I'm now doing, so when I say git commit m, when this with this password, what happens is the local machine, I have committed whatever changes I have done. I'm comfortable with that. I am committing it to the local machine. So this message, this has been committed to my local machine that boss, these are the new codes which I have created and it is ready. Now what I want to do, I want to push this code into my repository. So as soon as I do git push origin main. Now origin is what? From where I cloned this folder. So I cloned it from my GitHub repo. All that information is there in .git folder and in main. Main is the branch in which I'm working. You can see here main is written. So as soon as I do git push origin main, all of you, you see what will happen. It will push all the changes into my GitHub repo. So all of you, now if you see at my repo, you see there is no folder. But if I refresh it, can you now see that the folder which I was working on the local machine is available now on my GitHub repo? And you can see there is a message here that there is a commit with this message collab link. So you can see I can track here with the commits. We call it commit. This was the initial commit when we created the repo. The second commit was made when collab link folder was created. And this is how we are getting the readme collab link, readme.md and collab links. So here I am getting this two things here. I'm getting this link here. If you click on this, I also get the text file, and in this I have tagged it that this was a collab link on which we were working for the intro classes 1 to 4, Python intro classes 1 to 4. But I will also later explain you that GitHub is designed not for pushing data. It is designed for pushing codes. Large data, it is not designed for that. So I'm just pushing it now because all the data that we are working with are small data set. So I'm just pushing them. Rainfall, and there was a salary data, right? So all of you can see these are a few KBs of file. So I'm comfortable pushing them. Later I will explain you that this is not the correct way to push it, but there are other ways to push data. We will learn that later. For now, what is the command I should check? So you have seen I have made a new change. I have created a data folder in my local machine with 3 files inside it. So as soon as I do git status, it will say that there is a new untracked folder created data. Do you want me to commit it? So I will say yes, you add these changes into my code base. Now if I look at Git status, it will push it as green that okay, these are, I'm tracking them, but you please commit them. So what I will do, Git commit with a message, data files, and then if you, I will push it into my origin main. Now those who are doing for the first time, git push origin main, you will find that it will ask you to log in. So anyways, you see now there is no link or data folder I have already pushed. Why is it not showing? I just need to refresh once. You can see 3 commits. Third commit is what? I just pushed the data files. Data folder is created. All the 3 files that we worked on are here. I can also push now. Suppose Ravi has asked, can you push the hard data also? So let's push that also. So again, git status, you can see hard.csv is a new file. Git status, I want to add this into my repo. Git add dot git commit m hard file added, and then git push origin main. And now if you see, the hard file is also going to come up here. If I click on this, hard file is also here now. So whatever changes I'm working on local machine, it is showing here. Now what I want all of you to do is, I want you to clone this into your local machine. So those who are new, I know those who are pro, they will be finding it very easy. The activity what I want you to do, first one, is install Git in your local machine and then do git clone. Use this command in order to clone it into your system. So what I have done, what you need to do is go to any folder in your machine, create a new folder. Say I created a demo folder, and in this demo folder, go and open git bash here. And then just type the command git clone and the link of the file. So if you see here, git clone, if I do this, it will just pop up here. So let me do it again. Open git bash. So I hope Vinod, you are getting the clarity. Here I'm going to do what? I'm going to go git clone. So I'm going to take this clipboard. I'm going to git clone and then shift insert is copy paste and enter. So all of you can see now in my local machine, a second folder I've created of, and here it is showing in demo folder, it is showing the folder of online with all the files. So you need to also do the same. Delete. I'll just delete this one. I hope you know this was useful. Okay. Meanwhile, any of you others also just have a look. In settings, if I go to my repo, I can also add collaborators to this repository. So I can add whom I want to collaborate so that they also have on these codes. They can also start making changes in the code. So what we are going to do now, we are going to add to this repository some collaborators. So any one of you who wants to collaborate with me on this folder, can you give me your username of GitHub? I can find you and I can add you as collaborators on this folder, on this So what this means, others, I have sent you the invite. Few of you are still left. I will do that in some time. Manoj, I just add you. Others, please note, what I have asked Ravi to do is, Ravi, if you can create, say, a folder which is called OneNote, and what I will do is I will share. So what I'll request you is, I'll share this one link note with you all, with you. Can you create one folder with OneNote link, named as OneNote link, and in that you have to create one text file in which you copy paste the link of the OneNote which I have shared and push it into my repository. So I hope others are clear. So what I'm now doing now, I'm collaborating with Ravi here. I'm collaborating with Ravi. So we are working on the same project. He's creating a OneNote link folder, and then inside that he is putting a text file with the OneNote link, and then he will push it to the origin. Now he's a collaborator in my GitHub repo, so he should be able to push this into my repo. Okay. Similarly, others, If you want to do the same thing with my repo, please do it. But you name the folder as, say, OneNote. If your name is, say, Ravi, just add your initial, say, Ravi RS. Similarly, if Venkatesh, you want to collaborate, do OneNote VG. Just create your folder name with your initial so that I understand who is doing what, and then push it here. So if you see here, when I went to settings, I think one of you asked how we are adding collaborators. So for every repo, you go to settings, you check on collaborators. You can see that they have given here create an organization of your contributors. So what do you mean by this? The problem I was facing is I have to add you all individually. And suppose, so I'm just giving you the practical idea what is happening in industry. So suppose there are 10 members. Now in a project, say this is 1, 2, 3, 4, 5, till you have 10. Now tomorrow, what may happen is, say 2 has been moved out of the project and there is a new entry of 11th member into the project. Now, do you think it will be easy for the project manager to keep on adding, removing members? Yes or no? So it will be a lot of problem. You can imagine if there are 20 members in your collaborators, it will be a messy thing for you to every time ensure that the proper accesses are updated. So what they do is, in your company, they create one organization of your project. Say I call this the AJ project. And in AJ project, what I will do, I will add, suppose this is AJ at y.com. Y is the name of the company. So it is y.com. What I will do is, in my collaborators, I will just add AJ at y.com, and whoever are present as members in AJ, this organization or this project, they will automatically get access to my GitHub repo. Now what has happened, 2 has come out of the project. So what I will do, I will just update here that 2 is removed and 11 is added. So automatically this will start reflecting here also. I hope all of you are getting the security aspect of it. So in companies, you will always see that there are projects and project organizations, and inside that you add people, and this is how you can collaborate with people. Now, two things I want all of you to note, that throughout the coursework, we will keep on using Git and we will keep on using Python. So throughout the coursework, we will keep on learning new concepts in that. So it will be an ongoing process.